I'm not sure if I'm improving. I'm usually the happy hour blocker. Today I'm the lunch blocker. So I'll try to be really quick. Is it going? Okay. What do these four things have in common? The probability of a mine flooding, forecasting drought resilience in the Horn of Africa, forecasting fuel needs for the Iraq ground war, and the probability of breach. They're all highly uncertain, catastrophic risks, and most people think they're immeasurable, and most people would be wrong. So I'm just curious, are you people who think these things are impossible to measure? If so, I've got some good news for you. First of all, they've all been measured before, okay? And you don't have to be a rocket scientist. You don't have to be a nuclear engineer. You don't have to be a drug manufacturer. You don't have to be a movie maker who use these methods all the time to use them yourselves, okay? So my aim today is to convince leaders like you to adopt methods for measuring risk that actually work. That's why the title of my talk is Risky Business. Can we really measure cyber risk? So over the next 10 minutes, I'm going to cover two topics. The problem, that's our industry's concept, objects, and methods of risk, and the solution. We need more bookies, we need more robots, and we need more gambling. All right. Forgot my question mark. All right. So first, let's talk about the concept, object, and method of measurement. Let's start with the concept. For those who think something is immeasurable, this is the biggest obstacle for them to overcome, to get the right concept of measurement. And with that, I'm going to ask some pros to weigh in. First of all, Albert Einstein. As far as the propositions of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. Bertrand Russell. Although this may seem a paradox, all exact science is based on the idea of approximation. If a man tells you he knows a thing exactly, then you can be safe in inferring that you are speaking to an inexact man. Ron Howard, not the movie maker, the professor at Stanford, who's really the grandfather of decision analysis. Oh, and by the way, decision analysis is decision science's Nobel Prize winning big brother. Measurement is about describing our ignorance with numbers. I love that one. Measurement is about describing our ignorance with numbers. It's not about perfection, and it's not about, again, a specific number. Some of you might know this joke. So there's two campers. They're going to go out camping, go hiking. Before they go, one of them stops and starts putting running shoes on. The other camper says, "Why are you putting running shoes on?" He says, "Well, I heard there's bears out here." He goes, "Well, you're not going to outrun a bear." He goes, "Well, no, I'm going to outrun you." So measurement is about a reduction or improvement in our uncertainty so we can make better decisions. It's not about perfection. I actually think the security industry is mired in perfectionism. And we're losing. I think we need to stop. It's time to change. All right. The object of measurement. I love this quote. A problem well solved is a problem, a problem well stated is a problem half solved. So going back to Ron Howard, he's got a thing called the clarity test or the clarivoyant test. Imagine that there's a clairvoyant, but there's a problem with this clairvoyant. He's brain damaged. He's maybe an idiot savant. His specialty is he can predict or actually see into the future exactly. He can see the news, he can see other things, total clear vision. But he has no judgment, no discernment, can't make inferences. When you go about doing measurement, when you go about modeling, when you go about proposing, for example, your investments in the future to buy down risk, that's what security, that's what CISOs do. If you're going to pass the clairvoyant test, you need to be able to describe those measures in such a way that the idiot savant would be able to see whether that thing you're trying to measure happened or not. So to say, for example, were we breached? You'll get no response. To say, for example, is trust improving? You'll get no response. He won't know that. So how do we go about doing this? So let's talk about how would a clairvoyant see reputation damage from breach. First of all, how would you know you had reputation damage? I would think, like for example, in the case of Target, you'd expect to see less customers. You would expect to see less revenue. You'd expect to see less profits. These are things that all can be measured, right? And how about comparing stock prices after an incident? That's fairly deterministic. You could see after an incident, give it a few weeks or so, whether there was a change in stock prices. That's all public information, by the way. We have public information for public companies that have been publicly breached. That data is all public. So what does it look like? Actually, we've measured this. This is stuff from the book, by the way. Really, although you see a little dip out of Target, we actually don't have a lot of measurable impact of large breaches on customers. We don't see it. We don't see them turning away from companies, right? What we do see are things we call penance projects. What is a penance project? That is typically what a CISO does. We then go buy gear. We increase staff. We do things to then protect, actually, the reputation, because we will look bad if we don't do these things, right? But we actually don't see an impact from customers. These are the types of things, though, when we think about measuring risk, when we think about forecasting in the future, we need to start articulating those things in the future that would actually be measurable. All right, so the method of measurement. I love this quote, probably the most quotable man in the world. It's not what you don't know that will hurt you, it's what you know that ain't so. Don't let the perfect be the enemy of the good. You don't need to measure everything to start comprehending risk. The reality is that you can't measure everything. I know we're enamored with big data. I'm like the only advocate in security for small data. My name is Richard Seiersen. I approve of small data. Okay? It's not the size of your data that matters. It's how you use it. Small data works. Even beliefs as data works. You know, we wouldn't have Guinness beer today if we didn't have small data. The student t-test, I know you're probably not statisticians, it's a famous statistics. It was used to do predictions on crop yields. They were using very small, very uncertain data, less data than you probably have. We're just awash in data. And they're using it to produce beer, forecast, and make money. It's great. Love Guinness. We can measure highly uncertain rare events like breach. We can. We could actually measure trust. I know I just talked about that being a bad word. We can measure trust. In fact, intangibles are the things that move the world. People who get good about predicting and forecasting about intangibles are the people who are going to win. Those are the people who are going to be innovators. We need to learn how to think that way, though. Measuring intangibles is in, I've just said, okay, probability of breach. Let's talk about that. Method. What a jar of marbles can tell us about measuring breach. We're going to use marbles to measure breach. I recommend this. So, what proportion is red? Let's say that you didn't see this jar, and you know the jar has red and blue marbles in it. Let's say red represents breach, blue represents no breach. You draw 5 randomly. You get 1, 2, 3, 4, 5. You get 1. The proportion of red in this jar, and you don't know, this jar could have 1 billion marbles. It could have just this 5. You're not sure. You're likely, based on this draw, you're likely to have a proportion of red somewhere between 1 and 45%. That's highly uncertain. Again, go back to what Albert said, right, about math. You're still very uncertain. But you know a lot more than you did before. Before you had no idea. You're completely uncertain. Let's say you draw 15 more. Red now moves between 0.34% and 0.18%. Again, you don't know how many are in there, but you have more information than you did before. You're still highly uncertain. How about this? Randomly draw 75. Red, likely between 1.7% and 7.95%. You're getting less and less uncertain, right? Well, it just so happens that this is the last 2 years of breach in healthcare. So if you work in for Fortune 500, so if you work in a Fortune 500 company, we actually have all this data. There's no hidden public breaches, right? That doesn't make sense. No hidden public breaches. We know all about that. We also know the count of organizations in the Fortune 500. It's 500. We actually know exactly how many healthcare companies are in this, right? We know finance and otherwise. You can use this to start doing a forecast. So when your CEO or your board comes to you and says, you know, what's the chance of us being breached? You can say, well, it's somewhere between 1.07 and 7.95%. Actually, you probably wouldn't say that, but you'd say that it's possible. It's possible because we've seen it happen elsewhere, and we can forecast that it's likely. Let's talk about how you can use data like this once we get into the solutions. So here's my first recommendation for a solution. We've talked about the concept, object, and methods of measurement. Now we're going to talk about the solution. The first most important solution is you need to make better bets. You need to turn your staff into bookies. Bookies. When a bookie says something's 90% likely to happen, do you know how often they're right? Any guesses? 90%. When a bookie forecasts that something's 80% likely to happen, do you know how often they're correct? I'll let you answer again. You're great. Right there, too. 80%. So what's going on with the bookie? A couple of things. First of all, they're getting rapid, consistent, long-term, almost near instant feedback on their projections. It's not like way out there. It's not like projecting out who's going to win the election. They're getting regular, constant feedback. Secondarily, when we talk about money, when we think about money, when we forecast with money, there's something that happens intellectually and in our hearts. It just has a big impact. So even when we're make-believing and calibrating and training people how to make better guesses, we actually use money, even though there's no real money in play. It has an impact. And there's another thing that they have that's a major important perturbation, the fear of physical pain, either that they will inflict or that will be inflicted upon them. So you have this group of people who are very good. Why is this important? We need to start using methods that actually retain our SME, our experts' assessments and forecasts. We need to use methods that allow us, when we have these experts, which we invest in here in San Francisco, we're spending a goodness amount of money on security professionals. We need methods that allow us actually to retain and use their expertise as we go and look and do our forecasts about fighting the bad guy. Current methods that we use, things that come from, no offense to the consulting organizations, coming from like NIST, unfortunately coming from a lot of vendors, those actually exist to dilute the expertise of your experts. So we need to actually start creating more bookies. We need to start calibrating them and training them and using that as inputs into models. So we've done studies. We've actually done the largest study on this whole phenomenon, particularly for cybersecurity. And what we found is even when you're using a good model, a good survey, a good process, they're typically still 21% errors, right? And it's because we're human. You know, we just say things. This test right here is an example of where we actually the same question. We had a survey over thousands and thousands of security professionals, and we found out that, yes, guess what? They're 21%. They make errors all the time. So they might say one day, yep, that's really bad. We need to fix that. That's going to lead to breach. And then the next day, the same thing, they say, well, you can ignore that. That's exactly what happens here. Happens all the time. So how do we correct for that? We need to start making better robots. Are you familiar with the concept of expert systems? Expert systems are used a lot in epidemiology. They're used across a lot of different areas. It's where you start modeling experts, and those experts, and you aggregate their responses, they actually outperform an individual expert. It's used in disease analysis all the time. It's used across a lot of domains. That's what we've done here. We've actually doing a multivariate regression. You can go look at the book and download our spreadsheets and play with that if you like. But the idea is you can start actually going through and modeling your experts. You can start reducing, if not removing, that 21% error, getting that really small. So you can actually start creating a set of, again, little robots that run in the background when you're doing your risk management. You see in the bottom here, I have probability of breach given cloud, PHI, encryption, whatnot. So you start having these parameters that show up regularly. You start doing surveys with your staff. You can start doing cloud-sourced things like that and start building these models. Okay. Next, so how do we bring this all together? Gambling on the future of risk. Again, I've mentioned that we need to make bookies, we need to make robots. Now we're talking about how we bring it together. How do we gamble? So first of all, we can go through and start using our robots. Robot-generated probabilities based on bookie input. Again, based on the inputs of your staff. These are probabilities for certain types of events. A lot of our events in the generalized form are very recurrent. They're the same things that happen over and over again. Then you start having bookie-generated ranges of impacts. Right? Again, that's your staff making a generated range of impacts. And then you start having your gambling machine. Anyone here familiar with the concept of the Monte Carlo simulation? You've heard of Monte Carlo simulations? Yeah. That's what we're doing here, Monte Carlos. Really easy, really fast to do now in spreadsheets. You can do them actually on calculators. You can do them R, Python, you name it. So we can actually start going a little further with that. We can actually start gambling on the value of security investments too. Going back to that previous model, we can start looking at our investments. We can start saying, what is the impact from a probability and then a spend on these investments? Right? So risk becomes a curve, and we use it to bet on the highest impact investments that cut across risk. We start looking at the investments in our portfolio that have the highest impact long-term of bringing down that risk. By the way, I always get asked this, how do you go about working with executives to get their risk tolerances? Well, you always get your risk tolerance. You always get it. Every time you do or don't get your investment, that's an expression of your organization's risk tolerance. All right? Lastly, bringing it all together, gambling on the future of security, we can, if you work, so I work for some massive companies, right? Kaiser really big, GE really big, and I'm with a smaller company, but we can actually do roll-ups. This is something you cannot do with your heat maps, you cannot do with your risk registers because they're not based on math, you can't roll them up, you can't do forecasts, they're complete BS. We can start rolling up portfolios. You could have a portfolio, maybe you have a portfolio that's a region, it's a country, maybe a portfolio that's just cloud versus other, right? So you can start doing roll-ups of this risk and start getting an idea of what your overall risk curves look like. You can apply your investments and start saying, okay, what investments horizontally are going to get me the biggest return on investment? What's going to be at the lowest cost, the biggest buy down? I'm not saying that we automate away the CISO. That's not my intent at all. These things are things that help us to go about making better bets. They inform us how we think. The things that can be done with this, though, these can be fully automated. We can start having telemetry that's coming in from our systems. I was hearing about the last talk, AJ was talking about data. You can start having these systems update regularly, by the second even, right? So the parameters start changing. You can start adding alerts, all kinds of interesting work. This is important because when I look at our industry, when I look at things like security information event management, I look at vulnerability management, I look at threat management, I look at antivirus and management. The M's thrown on there, but they don't do anything, right? They use bad models. They create ordinal scales. They list things out. There's no modeling going on that tells you really what's important. How do you choose? How do you decide what goes first? I think this sort of modeling is really needed, not just for people like myself in making decisions, but for those of you who are innovating and looking at helping us to scale, helping us to think about the risks that you're helping us manage. So I talk really fast, I know that, but I'm done. Thank you.
Well, that was a nice sudden ending. That was
Thanks.
great, though. Thank you.